Hey students, how you doing today? I hope you're having yourself a fabulous Tuesday after that long weekend, and I hope your practice with your graphs went smoothly today so that your quiz tomorrow goes awesomely. Let's go ahead and take a look at what our last lesson for this chapter is. This is composition of functions. Now, you should be watching this on Tuesday night, this lesson, but if you really need to prepare for your quiz tonight, I think it's in this particular case, it's probably okay to not watch this video tonight. Take the quiz, like prepare for your quiz tonight. Take the quiz when you get to class tomorrow, and then once you're done with that, go ahead and watch this lesson. Maybe that timing would work out a little bit better. So if you're struggling preparing for your quiz tomorrow, watch this video tomorrow after you take the quiz. Now, if you're going to watch this lesson now, it is about compositions of functions. And before we talk about that, I'd like to show you this picture. Uh-oh, I just drew on my paper. I can undo that. Erase. Whoop. Sorry about that. Where did that picture go? That picture is right here. All right, this picture is of a turducken. A turducken. You have a duck that has been stuffed inside a chicken that has been stuffed inside a turkey. If you've ever met anybody who is really, really, really into Thanksgiving, like my good buddy Jason, every year Thanksgiving's got to be special in some kind of way. This year I'm going to deep fry my turkey. This year I'm going to invite 50 people over for Thanksgiving. This year I'm going to cook a turducken. And that's what Jason did one year on Thanksgiving. Anyway, whenever I think about a turducken, I think about composition of functions. Because you have a duck inside of a chicken, inside of a turkey. And that's kind of what composition functions are. It's one function stuffed inside of another function. Now, most of these first examples are more of a tur-chickens, if you will, because I have a function inside of a function. So that's just a single function within a single function. So that's just a normal composition of function problem, the tur-chicken of composition of function problems. Now, when you solve these, think order of operations. On the most inside parentheses is a 3. Nothing to do with the 3. So then you move out a parentheses. In this set of parentheses is g of 3. I can figure out g of 3. I'm going to do a little side work here. G of 3 is equal to 3 plus 4 quantity squared minus 5. Work out the math. 7 squared is 49. 49 minus 5 is 44. So g of 3 is equal to 44. So back over into this problem, we're going to change g of 3 in for 44 because that's what g of 3 is equal to. Now it says f of 44, and that's just a boring old f problem or function problem. So f of 44, start over, that's equal to this stuff with a 44 plugged in there. So I have 2 minus the square root of 44 plus 5. 44 plus 5 is 49. Square root of that is 7. And 2 minus 7 is negative 5. So that's our first composition of function example, a function within a function. Let's try another quick example right here. What about f of g of negative 6? Well, on the side I do my g of negative 6. So I have negative 6 quantity squared. Oh, wait, sorry about that. Negative 6 plus 4 quantity squared minus 5. Negative 6 plus 4 is negative 2. Negative 2 squared is 4. 4 minus 5 is negative 1. So g of negative 6 is negative 1. So what I'm really looking for is f of negative 1. And that's 2 minus the square root of negative 1 plus 5. That works out to be 4. Square root of 4 is 2. 2 minus 2 is 0. Okay, function within a function. Now, it's not always going to be f of g of a number. Sometimes it will be backwards. Let's take a look at example 3. So what if the g is on the outside? So g of f of 11. Well, same type idea. You just need to plug the f. You just need to do your f of 11 first, because that's what's on the inside of the parentheses. F of 11 is equal to 2 minus the square root of 11 plus 5. 11 plus 5 is 16. Square root of 16 is 4. And 2 minus 4 is negative 2. So instead of thinking of this as f of 11, we change it to a negative 2. G of negative 2, plug that into my g equation. So negative 2 plus 4 quantity squared minus 5. Negative 2 plus 4 is 2. 2 squared is 4. 4 minus 5 is negative 1. All right. So that's if you just have a number. Now, this last example. This is an example of something that you will see on the quiz and on the test. And what if they don't put a number in at all? What if they just say f of g of x? Well, we don't know what x is, and we don't really know what g of x is. Actually, that's not true. We know that g of x is equal to this stuff right here. So I'm going to write f of, insert my g equation. So x plus 4 quantity squared minus 5. These are the problems that confuse people. This is where, so now what I'm going to do is I need to use my f equation, and anywhere I see an x in my f equation, I need to plug all this stuff in. So 2 minus the square root of, here comes the x, so instead of writing x, I'm going to write x plus 4 quantity squared minus 5. That's the x, then plus 5. All right, negative 5 plus 5, that's 0. So I get 2 minus the square root of x plus 4 squared. And a little side note, we've talked about this before, that the square root of stuff squared is the absolute value of that stuff. Same idea here. This time the stuff is x plus 4 quantity squared. So this becomes 2 minus the absolute value of x plus 4. Just for fun, let's do an example 5 and go and do this problem backwards. So we're going to do g of f of x. Pause the video, see if you can get this one solved out by yourself, and then restart the video and make sure you did it right. All right, so I have my f equation. That's on the inside. So I'm going to use the g equation, and instead of writing f of x, I'm going to write what f of x is equal to, which is this stuff. So 2 minus the square root x plus 5. Then I take my g equation and I plug all of this in for my x here. So it becomes parentheses. Here comes the x, 2 minus square root of x plus 5. That's the x. Then plus 4 quantity squared minus 5. And they're going to tell you that you're going to need to simplify this. 4 plus 2 is 6. So this becomes 6 minus the square root of x plus 5, quantity squared minus 5. This particular problem, I think it's okay to leave here. In this problem this day, I don't see a problem. I don't see a point to moving past that answer here. Wait a minute. Yeah, because this 6 is stuck on the inside of the parentheses, and this minus 5 is stuck out. Anyway, function within a function. Now, you could also get asked some oddball questions like these. Here I have g of x. G of x is equal to this equation. It's kind of tough to see. Let me write it bigger. G of x equals negative 2 plus x minus 3 squared. Okay. f of x is this table, and q of x is this graph. And number one, I want to do g of f of negative 2. Well, on the inside of the parentheses is f of negative 2. That's up here. F of negative 2 is equal to 7. So what I'm really looking for is g of 7. So I use my g equation, negative 2 plus parentheses 7 minus 3 quantity squared. 7 minus 3 is 4. 4 squared is 16. Negative 2 plus 16 is 14. All right, so that was using a table and an equation. Number 2, what if it said q of g of 3? Well, on the inside is my g of 3, and this is my g equation up here. So I guess I'll do a little side work up here. G of 3 is negative 2 plus 3 minus 3 quantity squared. 3 minus 3 is 0. Square 0, it's still 0. I'm just left with the negative 2. So if g of 3 is negative 2, what I'm really looking for here is q of negative 2. And q of negative 2, if we go up to the graph, at negative 2, I have a value of 2. This is kind of a tough graph to see, sorry about that. We're doing q of negative 2. Q of negative 2 is positive 2. So q of negative 2 is positive 2. Okay, final example of my lesson today. The turducken of math problems. Turducken. It sounds disgusting to me. I never actually tried the turducken. I just remember Jason making it for Thanksgiving one year. But we have a function, q of 2, and another function, f, and another function, g. 3 functions, turducken-licious. So, on the very far of the inside, it says q of 2. If I go to my graph up here, q of 2 is equal to 1. So, I'm looking for g of f of 1. So on the, oops, sorry about that. So I changed my q of 2 to a 1. So now what I have on the inside is f of 1. And if I look up to my table, f of 1 is equal to negative 4. So what I'm really doing here is g of negative 4. And I can use my g equation for that. Here's my g equation right here. So g of negative 4 is going to be negative 2 plus parentheses negative 4 minus 3 quantity squared. Oops, sorry about that. So that's using the g equation. I just changed all the x's to negative 4. Negative 4 minus 3 is negative 7. Negative 7 squared is 49. Negative 2 plus 49 is 47. So the turducken function within a function within a function problem worked out to be positive 47. And students, that's composition of functions, the very last lesson of this particular chapter. Now, I do want to show 2 more lessons, and I'm going to show those lessons over the next couple days, but they're just things within this chapter that I find very interesting, but I'm not actually going to quiz or test them on. Tomorrow, I'm going to show a lesson on, well, between the next 2 days. I'm not sure between Wednesday and Thursday. But one of the days, I want to show how composition of functions relates to horizontal translations and horizontal dilations. You can use composition of functions to explain the backwards nature that we find when we're going inside of the function. I want to do that lesson one day. And then also, when I learned math, I learned that I learned about vertical dilations, and I remember learning about vertical dilations, but I never actually remember learning about horizontal dilations. So I'd also like to show a quick lesson on how you could completely avoid horizontal dilations. Andrew? Avoid them? Yeah, how you could avoid horizontal dilations if you wanted to. And I'll talk about that in one of the next 2 lessons. So they're kind of advanced lessons. They're not required for watching, but if you want to take your math understanding deeper, they'd be good to watch. And like I said, I'll put one out on Wednesday and one out on Thursday. And the stuff that you see on this lesson today, I'll have some practice for you on Wednesday and then Thursday, and we'll take a quiz on it on Friday. So that's the plan for the next couple days, and I hope you have yourself a fantastic Tuesday evening or Wednesday morning, whenever it is that you're watching this, or if you're having a good Wednesday night. Whatever. I'll talk to you later, everybody. Bye-bye.